Hey, welcome back to the channel. We are going to try to set up a new playlist, I think. And so what I want to do is a Codecrafters challenge. I've done some of these in the past, a couple in Zig, a couple in other languages. Go is pretty common for me. But I want to do the build your own Redis in Zig. So if you're unfamiliar with Codecrafters, let's talk about it really quick. So we can just go to Codecrafters. And I'm already signed in, so I don't think I get any of their marketing pages. But the short and sweet is that they're coding challenges that are a little more hands-on than, say, something like Code Wars or Leak Code or anything like that. And you're actually building like substantial projects. So, for example, there's build your own Redis, there's build your own BitTorrent, build your own shell, build your own DNS server, HTTP server. Interesting. I thought I finished this one, but oh, they have a new module for compression headers. So maybe I should go back and do this and go and finish that one out as well. The HTTP server is like a really interesting example because the HTTP server, for example, is starting from TCP. So you're actually building the HTTP layer on top of a TCP listener, which is really cool, especially if you don't know anything about HTTP or how that works. Building one from scratch is an excellent way to learn. So I really want to do the build your own Redis, so that's the one I'm going to start with. I use Redis a lot. I use it for work. I've used it for personal projects. I've never actually really thought too much about how it works under the hood. My hunch is that there's like, an event loop that is probably running and it's storing things in memory and maybe on disk. Maybe there's some sort of write-ahead log type thing. I don't really know. So my goal here is to learn more about how Redis actually works by building a instance of a Redis clone, I guess, in Zig. So yeah, we'll learn about TCP servers, the Redis protocol, and more. There are tons of challenges here. Maybe not tons, but there are quite a few challenges and tons of stages. These are all pretty in-depth. I will mention that Codecrafters is a paid tool. That being said, they run challenges for free during the beta. So if you want to build your own interpreter, this is for free during the beta. So sign up and do that one. You can also build your own Kafka, which is for free during the beta. And I say these are free. It is a paid product with like a monthly subscription. They also have a lifetime membership as well. I think that if you want to do any of these, you might be able to start on them, but I'm not sure if you can go through the entire program without paying as well. That being said, they did this thing a while back where every month they had a new free challenge, so they would just cycle through the challenges. So if you are watching this and you see that the Redis challenge is free and you want to knock it out in a month, follow along with these videos and we'll knock it out together. Okay, so let's see. I have started this one a little bit, so we're going to go ahead and hit retry. And you'll see a screen like this. Preferred language, Zig. We'll go with beginner. If you're just starting out with Zig, Codecrafters can be a great way to learn, to brush up on the Zig syntax first. Check out our recommended learning resources. That's okay. You can indicate how often you want to practice. We'll say a few times a month. And then you can get accountability, yes please, or I'll pass. So we can hit view next step. And I have a link that I'll share if you want to sign up. It like links your account and my account. And then if you do end up converting to a paid customer at some point, I think I get a kickback for that. So use that if you want, and then we can kind of keep track and see how everyone's progressing through these challenges. Okay, so information about setting up the repository. So I just started using Ghost TTY. And I have been really enjoying it so far, but I'll do a video on that at some other point. So I'm cloning into this Codecrafters Redis Zig repo, and I'm going to cd into that. So what we get is essentially this repo that is set up for us with a build Zig, a build Zigzon, Codecrafters YAML file that's for their platform, a source folder with our Zig in it, which is where we'll be making our modifications, and then a shell script to execute our program. So we need to push an empty commit. This is just making sure that the connection for Codecrafters is set up properly. And what we'll see here is we'll make this commit, we'll push this commit, and now that we've pushed this commit, it's executing our project. So it says our commit was received successfully. This is a turbo test run. You can learn more about turbo here. And then it runs tests on our code. We'll start to see logs, and then everything should pass, since this is just making sure, that we have completed the project. So you can see steps completed. You've completed this step. Go on to the next stage. Information on how to tackle this one. So the first thing we're going to do is bind to a port. Since this is the first stage, we've included some commented code to get you started. To pass this stage, simply uncomment the code and submit your changes. Sounds easy to me. So I'm going to open up Vim, pull up the project here, and then we can just hit %s// // and then / to remove those, and we should be good to go. I'm gonna let Zig formatter format this. We can write this and quit. Add get first stage passing. Let this commit, and then we'll push this. This is a turbo test run, so it should run pretty quickly. And once this runs, we should see that this is complete. So as this is running, I would just want to mention a little bit about how to use this. So you can go through step by step. So like the first step is navigate to this file. So you can hit mark as complete, and then it will show you, hey, here's the code that you want to uncomment. And it's nice. It shows it via a git diff, which is excellent. Nice and easy to read, at least for people who are, working in the industry and reading git diffs all the time. And then submit your changes. So there's information on how to submit those. So in our case, our tests have passed, so we can mark the stage as complete, and then we can move on to the next one. So the next one's going to be to respond to a ping, which we simply are going to respond with Pong. So let's go ahead to the stage. So unlike stage 1, your repository doesn't contain commented code to pass this stage. Also, a fun little tidbit, 98% of users who attempt this stage complete it. That's pretty good. Head on over to your editor and implement your solution. So the steps become more vague now that we are actually getting into the swing of it. As we start to find the more and more complicated ones, like implementing the echo command where they recommend building a parser, what we'll see is the steps become a little bit more involved again. So they're kind of hands-on, kind of hands-off, really depends on what you're working on. For the sake of responding to a ping with the code that we already have, we don't need a lot of hand-holding, or at least in my case, I don't need a lot of hand-holding. So all we're going to do is come down here, and where we are accepting the new connection, we just want to try connection.stream.writeAll, and then we just want to write, let's see, so it's plus pong/r/n. And we can find that information down here. Sorry, I kind of got lost on where it was at. So the task is right here. In the stage, we'll implement support for the ping command. Redis clients communicate with Redis servers by sending commands. For each command, a Redis server sends a response back to the client. Commands and responses are both encoded using the Redis protocol. We'll learn more about this in later stages. Ping is the simplest command. It's used to check whether the Redis server is healthy. The response for the ping command is this, which is what we just typed. This is the string Pong encoded using the Redis protocol. We'll get to that later. In this stage, we'll cut corners by ignoring client input and hard-coding Pong as a response. You'll learn to parse it in later stages. Here's how it tests your program. So it'll execute your program.sh, and then it will send the ping command via another process to your server. So your server should respond with Pong, which is Pong encoded as a RESP simple string. And then there's some notes. So for example, the exact bytes your program won't receive won't just be ping. There'll be something like this, which is the Redis protocol encoding of the ping command. In our case, for this stage, we can just say, hey, if we get a connection, just write Pong back. And if you've ever done TDD, what you'll find is that a lot of the Codecrafters challenges are kind of structured like good TDD. So you have a single test case in front of you, you make that single test case pass, and then you get another test case. And some of those test cases will just add new functionality, and some of them will require you to refactor and grow your existing implementation. So we'll just say Pong for this one. And you obviously come up with better commit messages if you are making an actual project and trying to follow along to make your own Redis clone that is substantial or something. But for my sake, I'm just doing this to learn. So again, we're running our tests. The UI has indicated that it is running tests. So you can actually look at the logs here too if you care to see them. Tests pass. That was pretty quick. So if we go back, there's no going back. If we close this, we can see that tests have passed. We can mark the stage as complete. So this is pretty good. We'll do a couple more videos. We'll actually probably stop right before we get to implementing the echo command, because at that point we'll want to build a parser, and that probably should be its own video. So we'll get a little further, and this will be handling multiple pings. So let's go ahead and hit the next stage. In this stage, you'll respond to multiple ping commands sent by the same connection. So currently, the test only sends a single ping command, and that's it. The Redis server starts to listen for the next command as soon as it's done responding to the previous one. This allows Redis clients to send multiple commands using the same connection. We're learning about Redis as we go, which is great. That's my goal. The tester will execute your program like this, yourprogram.sh, and then it will send multiple ping commands using the same connection. For example, it might send ping, ping via the Redis CLI. The tester will expect multiple Pong responses, one for each command sent. You'll need to run a loop. Okay, thanks for the tip. One thing that's nice too is if you get stuck, you can view code examples. So there may come a time, there was a time in the Go HTTP server where I was kind of confused as to how other people might implement something. So I clicked on code examples, and then in the case of not completing the stage yet, it tells you haven't completed it. Are you sure you want to look at the code examples? We're going to solve this one on our own first. So we're going to hit no, go back to the instructions. Additionally, you can look at the test cases, which is kind of cool. They are, this is maybe not as, this is the test case. I was expecting a little bit more, but all we're doing is running ping multiple times. And then finally, there are these screencasts for people who make screencasts. So if you want to follow along with someone like myself, you can do that. And that might end up making its way to the screencasts here at some point as well. Okay, let's actually solve this one. Gonna fire up Vim again. And what we need to do is we need to handle actually reading the connections. So we're accepting the connections. We are calling listener accept. And what we need to do now is essentially create a reader. So I'm going to say const reader equals connection.stream.reader. Okay. I'm going to create a buffer to store the contents of the reader in. We'll say 1024. These are going to be U8s. And by default, I'm going to set them to undefined. Now that we're here, we can use a while loop and use a while try reader.read, and we want to read that into the buffer. And the value that's returned by this is the number of bytes that have been read. So if the number is greater than 0, let's continue with our loop. So what we want to do in this case is we can just take this and move it to right here. And as long as we are reading bytes from the buffer, we're just responding with Pong. Finally, we close our connection stream. Let's commit this. Support multiple pings. Maybe. And push this. It's running our tests. And I think this one should pass. So let's give this a shot. Yeah, test pass. Perfect. All right, so mark this stage as complete and move on to the next one. This will be the last one we do for now, and then the items that we're getting into start to get a little more complicated, so we'll break those apart into smaller videos. But this one, we'll do one video for everything we've done so far, and that'll be a good start to get us started. So in this stage, we're going to add support for multiple concurrent clients. Yeah, this will be a good spot to stop after this one. In addition to handling multiple commands from the same client, Redis servers are designed to handle multiple clients at once. That makes sense. To implement this, you'll either need to use threads, or if you're feeling adventurous, an event loop. Hey, I was right. Like the official Redis implementation does. We're just going to stick with threads. Using something like, oh man, I don't remember what the libvex or libx or something. Using something like that event loop might be nice. It's Zig event loop. It'll be the first thing that comes up. libxev. This seems really cool. I'm not going to try to shoehorn this in for the sake of learning more about Redis. So we'll use threads and we'll do a thread pool because that seems like the right way to handle threads in our case. So let's get started. Pull up Vim again. I probably need to stop closing Vim and just commit and push from Vim, but that's okay. So we're going to work with a thread pool. So try standard.thread.pool.init, and this takes in a pool and then options. So we don't have a pool yet, so we need to indicate that we are getting a reference to a pool that we'll create in just a second. And we have some options, and I think the key option that we really need to worry about is that we need to pass in an allocator. I think in jobs also. So we have the number of jobs that the thread pool can handle. We'll set this to 32 for now. That's kind of an arbitrary number. We can adjust that later if we need, but for now, 32 seems pretty good. So we need to define our pool. This is going to be a standard thread pool, and we can set that to undefined for now. And then we need an allocator, right? We don't have one yet. So let's create a GPA, and this is going to be standard heap general purpose allocator. There's a config. I think we should be good to set it to the default. And then we need to get a handle on the allocator. So const allocator is equal to GPA.allocator. That should be good. I'm going to go ahead and write and let this format itself. We can remove this standard out print. We don't need that. We can remove this standard out print. We don't need that. We can remove standard out since we're not printing to it. We don't need that. So yeah, I think we should be good there. So we have our thread pool. What we need to do is essentially spawn a new thread to handle a connection. So when we get a connection, we want to say something like try pool.spawn, and then this is going to be a function. So I'm just going to call this handler, and then the args that we want to pass to this function. In our case, the only arg that we really want to pass is the connection. So handler doesn't exist. So what we can do is we can grab all of this and delete it. Come down here and do a function handler. This handler needs the connection, C-O-N-N-E-C-T, connection. And it's going to be a net server.connection because that's the type that we are using. It is going to return void. And one of the things that's really interesting about that return type is that there's no error union for the return type. So while I'm pasting this here, we run into an interesting scenario where this try is potentially going to return an error if it can't do the thing it needs to do. Same with this try. So let's clean these up because the unfortunate reality is they're not going to work. In fact, maybe one thing we should talk about too. I'm just going to go ahead and write this and I'll quit. So I've been pushing my changes and it's been building them and running them. But one thing we can do is we can try to build locally. And if we try to build locally, we'll see that error. Yeah, exactly. So this error right here, you can see, well, two things. Expected type void found, an error union with that output. So if we were to change this and try to address this by saying, hey, it's okay if we return an error from our handler function, we'll run into another issue, which is just as interesting. You can see here that the error union is ignored. So we can consider using try, catch, or if. The fact of the matter is that the pool API does not allow you to execute a function that has an error as the return type. So we have to handle that in the handler. So we can't use try here, but what we can do is we can use catch. So what we're going to do is we'll change some of this. Let's take this and set this to a while true. and let's just run this bad boy until we can't. And then the very first thing we want to do is something like const bytes read, and then we'll take the line that we just removed, which was reader.read. We need to give it a buffer. And then if we have an error, we'll just break. Might not be the best way to handle that, but it works for now. We also want to check if bytes read is less than or equal to 0. Well, we don't want to return anything. We just want to break. Go ahead and exit out of this loop. Otherwise, we need to do the connection.stream.writeAll pong, which should be good. The last important thing that we're missing here, we can't use this try. So instead of the try, we'll do a catch. And I don't really know what we want to do, so I'm just going to put a to do. Unable to write to stream. Handle this. This should get us to the point where we can pass our tests, though. So let's go ahead and write quit. Let's do a Zig build just to make sure it builds. It does. Okay, good. Get status, get add, and then we'll just commit everything. So get multiple connections working with a thread pool. Seems like a good commit message. Once this commits, we'll push it. And then we will make sure that this runs. Okay, so we can see the output from our tests. So it's running. You can see we're pinging, we're ponging. There are different clients. This looks pretty good. Another test here, responding to multiple pings. Another test, another test. Looks good to me. And we can see test pass. You can move on to the next step. Test passed here. Mark stage is complete. View next stage, and we're going to stop right here. But I will mention what we're going to do next. So in this stage, we're adding support for the echo command. Echo is a command like ping that is used for testing and debugging. It accepts a simple argument and returns it back as a resp bulk string. Full disclosure, I have done this, not the whole Redis project in Go, but I've done a chunk of the Redis project in Go, and this was the point where I realized that I was just kind of cowboy coding and just looking at the strings that were coming in and working with those strings directly. In hindsight, this is where I realized that I should have built a parser and parse this into a struct, and then execute it on the struct. So we're going to stop here because the next video is going to be big because we'll do that. We'll set that parser in place. And I think they recommend, we recommend that you implement a proper Redis protocol parser in this stage. It will come handy in later stages. Yeah, no joke. So we'll do that in the next video. It seems like not a lot because basically when you echo something, we'll send it back. But the reality is that we're going to actually build a parser for all of these commands that come in. So hopefully that sounds interesting, and look forward to that video shortly after. Again, thanks for taking the time to watch these videos. It really means a lot to me to have your support and your time. I know your time's valuable, so I try to make good use of it. If you haven't yet, subscribe to the channel and hit that bell wherever it's at so that you can be notified of new videos, especially for this playlist, because if you start this, I'm sure you want to finish it like I do. So don't miss those videos. And then I think that's it. Have a great day.